could be a dream. Life could be a dream. Shaboom. Life could be a dream. If I could take you up.
A sine function has a curve that travels up and down and repeats every 2 pi radians. A sine graph starts at 0 and goes up to 1 and goes back down to pi, then goes down to -1 and back up to 2 pi. A is the amplitude, which moves the graph up or down. It is the distance from the center to high or low. B affects the period of time for one cycle. You can find the period using 2 pi over b. C moves the graph left or right. It is also called the phase shift. You can find it using c over b. D moves the graph up or down. These are the equations for the sine and cosine graphs. For the data I was given, I chose to use a sine function because it best represented my data.
A cosine is just like a sine, except it starts at 1, goes down to pi over 2, then to -1, then to 3 pi over 2, and back to 1. A cosine and sine are very similar, like in this graph. If you shift the cosine or the sine, you can make the graphs match perfectly. To do this, you can change the c part of the equation, which is the phase shift. For example, that's what we did for our graphs to make them match as closely as possible. Harmonic motion can be produced when a force that reaches equilibrium is opposite from the displacement of the equilibrium position, and the magnitude is proportional to the displacement.
An example of harmonic motion can be found in a swing set. This can be best represented by a cosine graph. Another example can be found in ukulele picking. The vibrations in the string can be represented by a sine or cosine graph. Harmonic motion also takes place in the motion of this jump rope.
The purpose of this project was to realize harmonic motion can be seen in everyday things and how math applies to everything. Sine and cosine equations are important because they can be used to determine radio broadcast, electrical currents, high or low tides, and as seen in this project, how the sun sets and rises.